Hi everyone, good morning. So now we're moving into our project showcase portion of our program. So connecting faculty and researchers with the city's innovation ecosystem through our corporate innovation and entrepreneurship portfolios are really central to what we do here at the NYC Media Lab. We know that pairing university talent with innovation, tech, and R&D teams from our member companies accelerates the pace of innovation across New York City. So to kick things off, we'd like to welcome Alireza Zarian from Professor Shih-Fu Chang's lab at Columbia University. He'll talk about our project with Hearst, one of our member companies, and show how machine learning is transforming computational connections across video, text, and multiple platforms. So Alireza, welcome.
Good morning, everyone. My name is Alireza. I'm going to present to you a recent collaboration with the Media Lab and Hearst TV. I'm a PhD candidate in Columbia University Digital Video and Multimedia Lab, which is led by Professor Shih-Fu Chang. And my friends Spencer Whitehead and Professor Heng Ji work with us from University of Illinois. We've all heard of big data, but much of today's data is multimedia, which is not only big. Went out? Okay. This multimedia is typically stored in an unstructured, disorganized way that is difficult to harness. A big portion of multimedia is text, and in the past decade, natural language processing research has made enormous progress on extracting structured knowledge from text. A typical knowledge extraction system would take this article and extract crash as an event. Sacramento was the place of the event. Red pickup truck was the vehicle involved in the event. And there are other events and there are other entities, and this knowledge grows bigger and bigger as you feed more and more data automatically stored in a database, in a rich, interconnected database that enables various downstream tasks, such as search. You can ask complicated queries from this system, and it can automatically search in the database and find documents that match this pattern and retrieve to the user. So this is great, but a large portion of multimedia is visual data, and natural language processing does not work, cannot extract knowledge from that. So in the past couple of years, we've been developing technology from computer vision to extract knowledge from visual content, like images and videos, and integrate that with the knowledge that is extracted from text. This knowledge typically adds more information that is missing from text, that is not mentioned, like details. And sometimes it also adds visual illustration that is necessary to really understand the event. So it is a key that enables even more applications. For example, in a recent collaboration with Hearst TV, we studied the application of multimedia knowledge extraction in news production. Hearst owns several local news channels, and in local news, it's important to create a story and report the incident as soon as possible, like be the first to report that. But the process of transforming the raw footage into video that is ready for newscast that summarizes the key content of the story is usually a tedious process, and it basically needs editing the video, which is slow, and we'd like to automate that. So we designed a system where we feed the raw footage into the knowledge extraction system, and it extracts a multimedia knowledge graph, which then is used to automatically edit the video and extract edit video and summarize text. So this is a real story from the KCRL news channel provided by Hearst. And in this system, we can first extract various kinds of knowledge elements, such as events, entities, and objects and faces. We can recognize faces. We can extract relationships between them and the role the entities play in the events. But more importantly, we extract connections from image to text and from text to image. And these connections are actually what enables us to meaningfully summarize the video. Because when you know the red pickup truck that is mentioned in text is the same as the one shown in that frame of the video, you can include that shot in your summary in the newscast video because it's important. And when you want to show sheriff, you can include the shot that shows the sheriff. So this cross-media connections are the key that enables us. And this is an active area of research, very challenging, and every day we are developing new technology to make it better. As an example, just last month, we made a breakthrough. We are now able to discover names for new people, unknown people, automatically from raw data without any human help. So what does it mean? Imagine you have a new movie with new characters, new faces, and new names that you've never seen before. Our system is able to automatically watch the entire movie, read the script, and learn to connect names to faces, learn the name of characters, and learn to recognize their faces in future. And this is very challenging. Without human help, it's very challenging because there is a natural ambiguity in this kind of data. There are many faces, many names, and it's unclear who's who. But our system doesn't need human help. It can automatically discover and link the faces to names. It's important to note that face recognition technology does not work here because it needs precisely and manually labeled face examples, which doesn't work, which basically needs manual effort and doesn't work in time-sensitive applications. Feel free to visit our website to track our research. Some of our tools, some of the software that we've developed that currently are state-of-the-art are actually publicly available. So definitely take a look. But we're actively working in this area to improve our system. We're trying in a project to give reasoning capability to this AI system that makes it smarter. And we're also interested in expanding the applications, applying on other domains such as healthcare, anywhere basically that you have image, like medical images, and you have text, like medical notes, and you want to extract information in a unified way, you can use this kind of technology. So we're open to collaboration, and feel free to get in touch. Thank you.
Thank you, Alireza. Fascinating work. Now we'll move into our collaboration with Havas, a French advertising agency, and introduce a team from NYU's Tisch School of the Arts ITP program. This project explores the important topic of accessibility tech and how inclusive design is critical to making sure that tech is built for and by everyone. So to that end, I'd like to welcome James Huerta and David Rosenbaum to the stage.
Thanks, Erica, for having us today. Dave Rosenbaum from Havas Media. As Erica mentioned, we are, for those of you who don't know Havas, we are a fully integrated advertising and media company. We're part of the Vivendi group globally. Excited to be here today. We've partnered with New York City Media Lab now for the past 2 years, and we're going to go into our third year starting on 2020. This past year, we worked on a project to sort of solve a very simple problem, the future of transportation in New York. So not too daunting, but it was great to have several schools participate in the program and think about how they can use data and technology and communications to solve the problem. We had a wide array of solutions and different aspects that the teams looked to solve, whether it was congestion, mobility, time, quality of commute, and accessibility. And today we're going to introduce you to the team from the team Access to Places that address the accessibility aspect of transportation. And several other teams are going to be demoing their solutions as well this afternoon. So please give it up for Access to Places.
Hello, everyone. We're really thankful to Havas and the New York City Media Lab for being here today. The partnership that we've had over the past semester, the spring semester. My name is Antonio.
My name is Rashida. My name is Emily.
And we are graduate students from NYU at the Interactive Telecommunications program. If you look to the person to your right, look to the person to your left, I'm willing to bet that one of you has been late because of the subway in the past week. And so we're here to talk about the subway accessibility for people who are blind and visually impaired. So accessibility is a real issue for people who are blind because of the signage in the subway system. For many of us, New York City is a dream city, but it falls short in important ways. We all know subway stations that frustrate us. How is Penn Station at rush hour? How is Penn Station at rush hour for people who are blind? Frustrations for blind travelers tend to stem from a few key reasons. Many stations lack clear signage. Station layouts are widely varied. And service changes or delays are not well communicated, if at all. It can get pretty difficult to figure out exactly where you are and where you should be headed. Blind people are affected most by this lack of organization and structure. To solve some of these problems, we've prototyped a mobile application to bring the layout of the system into mobile devices.
Working with a team of mentors from Havas, we started our research process by speaking to many blind users who are active in the accessibility community of New York. What we heard about their experience informed both the content and form of our mobile app. A few things really stuck out to us. Several of our users we talked to mentioned that they had to do a great deal of research to prepare for travel. Take Stephen, for example. Before even entering a subway station, Stephen reads about the station's Wikipedia page in order to find its entrances and exits. Others had to rely on more impromptu methods. For Nihal, she often has to ask 2 to 3 people when she's in the subway station for help. And while most people are well-intentioned and it gets much busier, it gets much more difficult during busier times. In order to address these concerns, we've prototyped a mobile app that takes the content of physical signs and screens and makes it accessible to blind users. We focused on making the most critical information structured and navigable. Let's take a look at what this app looks like in action.
Using your phone's native voiceover capability, it provides details about platforms, arrival times, and more. With access to places, blind riders can travel with the confidence, knowing they have the information they need.
The format you saw is a visual layout, but it corresponds to the ways in which that information is delivered by voiceover. We tried to match user expectations about where they might find descriptions by mimicking existing transit apps. The critical difference is that for our key audience, we presented some information in a more detailed manner. This was born out of our initial user research, in which our users noted a few things as both high priority to know, but difficult to ascertain. This information included information about entrances and exits, platforms, arrival times, and service changes. We balanced providing granularity with the need to keep that information relatively lightweight. And by breaking up some of the items into their own screens, we make it easier to move between the information you need while ignoring items you do not require. For example, to find entrances and exits, users select a line on a station and then can click into the specific information that they seek. To describe entrances and exits, we paid particular attention to features that were both salient and helpful. For entrances, we note the street intersection and the nearest platform, detailing the direction and the closest train. For exits, we take on the perspective of the rider of the train, noting the nearest street intersection in relationship to the cars of the train. We've already begun to test the current version of the application with our community of blind riders. We've received valuable feedback that helped us, for example, understand the level of detail users would want in the entrance and exit descriptions you just saw. Ultimately, we imagine access to places as existing in a larger ecosystem of solutions. If our user interviews have taught us anything, it's that real accessibility will require multiple solutions working in tandem. To get a final form into the hands of our users, we can begin by sharing a beta version with the communities we've already connected with, such as the National Federation of the Blind, the New York Public Library, and Learning Ally. Because the core of Access to Places is really an idea about how to structure transit information to make it navigable, we believe it'll scale smoothly to other cities. We don't see this project as the end of our push for accessibility, but rather the beginning. Thank you.
Access to Places. Hi everyone, I'm James Huerta. Before we go, just want to quickly announce the challenge for 2020 that we are formally announcing today with more information to come. This will be the Lean Venture Studio for retail. So the topic area will be retail. There's a lot of noise about kind of e-commerce and how that's affecting or killing traditional retailers. We know from our research, though, that there are huge opportunities for more traditional retailers to evolve in that space because the majority of consumers are looking for more entertaining experiences. They still love that surprise of entering a physical space and seeing something that they didn't expect. They feel that those retailers are more connected to the community as compared to, the behemoths like Amazon and Alibaba. And so we'll be looking for university teams and startups who want to do customer discovery and market validation process. We're going to be involving some of our own retail clients at Havas in this challenge this year. And more information to come. Do sign up if you're interested in knowing when the challenge opens in the next couple of months, but look forward to that. Thank you so much, and thanks to our leadership for continuing to support our partnership with NYC Media Lab, and we'll see you soon. Thanks.
Thank you. Thank you, James, David, and Access to Places. So now we're excited to showcase a startup that just completed the Combine, which is our venture platform for university-affiliated early-stage startups. Retina Technologies uses virtual reality applications and immersive tech to increase access to vision screenings, which currently requires prohibitively expensive equipment. So let's welcome Andrew Warburton and Alex Serafini from the Icahn School of Medicine at Mount Sinai to the stage.
Good morning, everyone. I'm Alex Serafini.
I'm Andrew Warburton.
And today we're here to talk about a med student-led startup called Retina Technologies. Our goal is really to leverage emerging portable technologies like virtual reality to increase access to vision screening one day, hopefully globally. But because this is really a media conference, one thing we want to bring up is this question of, are portable technologies, emerging technologies like virtual reality, a fad? Now, because all of you are here and because we're here, we definitely hope the answer to that is no. But if you look at the data here, especially the red bars as it's relevant to us, you can actually see the beginning of a plateau in revenues aggregated in this industry over time. And it's only really been active for a few years. So this is something that, surprises us, that we didn't anticipate to happen so early. And this data was published in 2019, and that's really when we started fleshing out what we wanted to do with Retina Technologies. So as medical students, we realized, okay, there are several use cases for virtual reality in medicine, and not many people have started mobilizing those use cases yet, so we weren't really sure why that was happening. So one reason we came up with is that there aren't many New York cities around. If you look at New York City, you have amazing medical institutions that provide students and doctors and access to intellectual property management. You also happen to have amazing accelerators for very early ideas that can not only provide guidance, but it also ends up providing some infusion of capital sometime. And that's important because you really start legitimizing some of these ideas that medical students like us might have. Now, when you match it with the fact that New York also has access to venture funding, pharmaceutical venture branches, and also angel investors, of course, you end up having this ingredient list that allows you to grow these ideas very well. So we're confident that we can do our idea, which we'll talk about momentarily, because there are several cases that these ingredients have been used to create something successful. One example here is NYU. Very recently, MetaViz was launched, and they're basically repurposing augmented reality for surgical training. And this was actually FDA approved, which was amazing, and a lot of people were surprised. And they basically leveraged all these different touch points within the New York City ecosystem to make that happen. So now we're trying to source some of the same ingredients in this situation to build out Retina Technologies, instead using Mount Sinai and just finishing up the New York City Media Lab accelerator. So how are we going to do this? We're interested in ophthalmology, obviously. And one of the things that we came to notice very quickly is that for optometrists and ophthalmologists, the most prohibitive factor for really having efficient practices is how expensive technologies are. The other fact is that we're in a huge shortage of ophthalmologists and optometrists. About 25% of the counties in the United States don't have either an optometrist or an ophthalmologist, which forces people to have to go out of their way to get screenings, and as a result, people aren't getting screened as often. So we figured if you can take a portable device and match it with some more sophisticated software techniques like machine learning, you can now put this capability in the hands of people that aren't specialists, where you have more touch points with customers, such as CVS's and Walmart.
And that's exactly where Retina Technology is going to come in. Right now, we're building a virtual reality platform and using the power and portability of virtual reality to provide widespread vision screening for patients across the country. 80% of visual deficits can be prevented from increased screening access. And this will allow high-risk patients, like glaucomatous patients, to go see the appropriate specialist that they need. Our platform consists of a virtual reality software, as you can see in this video. We also are constructing an automated non-refer algorithm to help non-vision specialists get patients to the specialist that they need to go to. And amongst this, we'll be also collecting and centralizing patient vision data, so we can have the first time course data of functional vision data that's ever been collected. So our team is a group of 5 medical students from Mount Sinai, and we have a breadth of knowledge ranging from ophthalmologic clinical experience, former startup development, business development, AI, algorithm implementation, hardware development, and computer science and biostatistics. We've utilized all of our knowledge bases to really bring this product into fruition. And through the Media Lab, we've met amazing individuals such as VR developers like Vicente and other industry giants in optometry and academic leaders in the field across the country at Stanford. So this is really the summary of our value. We are bringing increased access to vision screening across the country. We are providing a non-refer algorithm so that non-vision specialists can have an easier time getting patients, high-risk patients, to the vision specialist that they need to see to prevent vision loss, and we'll have the only centralized functional vision data set available. This will completely change the vision screening environment as we know it. Not only that, we have invested in a robust pipeline to construct retinal imaging technologies within this headset, and we'll also have implemented increased mobility for this technology to go across different platforms to reach more people across the country. Ultimately, what we're looking for is people who share the same vision that we do, whether you can provide clinical experience, hardware development, software, VR development, or even an investment. We want people who are just as passionate as we are about preventing blindness and vision deficits across the country. As Alex mentioned, there's a huge deficit of ophthalmologists, and so we need to get increase vision screening into the hands of everyone. So thank you so much.
Thank you, Andrew and Alex. Our next presentation is a new collaboration between Hakuhodo, a Japanese advertising agency, and Columbia University. Let's take a look at why they are exploring the next generation of immersive technology and the amazing experiences it'll unlock. Please welcome Masato Aoki from Hakuhodo and Professor Stephen Feiner from Columbia University.
Hello everyone, my name is Masaoki of Hakuhodo. We have just joined New York City Media Lab in September 2018, and this is my first summit. It's my pleasure to be here on this stage to share what we are doing. Let me quickly introduce who Hakuhodo is. Hakuhodo is one of the largest agencies in Japan, established in 1895. And has over 100 years history. We are the oldest agency in Japan.
Okay.
Now, we are one of the world's top 10 agencies. We provide full service, but our focus is always on seikatsucha. Seikatsucha is Japanese word, which means living people with their own lives. Seikatsucha is a much bigger and deeper concept than the traditional word consumer. Focusing on seikatsucha is our philosophy. I am from R&D department of Hakuhodo, and we are developing new technology solutions which may impact on new types of communication. We believe that advertising industry is now facing drastic change and transformation once every 100 years. In past 10 years, every information has been digitized, and digital information is now everywhere. When we look at next 10 years, we believe every moment of our daily life is going to be digitized. All the people, automobile, home, store, city, screen, and everything is going to be connected and interacted digitally in the future. In this digitally connected world, we are aiming to produce new communication interface between human, things, and brands, and establish brand new communication service. In order to produce new communication service for digitally connected world, as a corporate member of New York City Media Lab, we have been collaborating with Professor Stephen Feiner's lab at Columbia University to prototype AR cloud application shareable among multiplayer in real time. Now, Professor Stephen Feiner is going to give you a quick introduction of what we are going to develop. Professor Steve, please.
Thank you very much.
Thank you.
Okay. Thank you, Susan. So my name is Steve Feiner. I am a professor of computer science at the Computer Graphics and User Interfaces lab. So my lab has been doing work in AR and VR for many years at this point, emphasizing the development of user interfaces and of software infrastructure. And so just a brief overview of some of the stuff we've done. We've worked in navigation, doing some of the very earliest outdoor work in the mid-90s with AR being used to help people figure out where they are and how to get to where they're going. Visualization, collaborative AR and VR visualization, including work that we showed on urban visualization last year, which you can see in the center, and quite a lot of work on skilled task assistance with multiple people working together. Some of the domains that we explore currently include the use of AR to guide physicians during minimally invasive surgical procedures, motor rehabilitation with people working together, not physically co-located, courtesy of the low latency of very fast networking, as we're going to be seeing with 5G, and a variety of things in collaborative AR and VR for assembly and repair of equipment. So what are we going to be doing together with Hakuhodo? We've just started a collaboration which is going to center around the development of handheld AR. Games, basically, with multiple people interacting with each other, as well as with virtual objects and the physical environment around them. So since we've just started, I don't like showing fake pictures, so I'm only showing you the back of a phone right now. And I hope that next summit, and maybe even before then, we'll be able to go and show you with live demos some of the stuff that we are going to be working on. Thank you.